In this video, we shall find the unbiased minimum variance unbiased estimator for the Poisson distribution using the Cramer-Rao inequality. For more on this topic, you need to subscribe to this channel. We are given the PDF here. The first thing to write, solution, is to recall that for the Cramer-Rao inequality, it was given as 1 all over n multiplied by the expectation of the differential log of the given function all over the theta all squared. So this is our Cramer-Rao inequality. The next thing to do is to find the log of the given function. We also differentiate with respect to theta of the given function. We take the expectation and multiply it by n. We now compare it with the Cramer-Rao inequality. When we do this, we have succeeded in finding the UMVUE. That means the minimum variance unbiased estimator of the Poisson distribution. First, given our PDF of the Poisson distribution, which is theta raised to the power of x exponential negative theta all over x. We take the log first, take the log. Taking the log rating, we have ln f of x to be equal to, if we take the log of this, we'll have x ln theta. We take the log of an exponential function, we have that same function, while the exponential value goes. Now, we also have x, which is minus ln x. So this is what we'll get when we take the log. The next thing to do is to differentiate with respect to theta. So we differentiate with respect to theta. If you find this video helpful, you can subscribe to this channel. So if we differentiate with respect to theta, we'll write it as the differential log of our PDF all over the theta. What will it give us? That means the whole of this is what I have written here. The whole of this inside the Cramer-Rao inequality is what I've succeeded in writing here. So we are finding the differential of this function. So if we find the differential of this, if we differentiate this, we'll have x all over theta. If we differentiate this, we get 1. If we differentiate this, we get 0. So we've simply gotten x all over theta minus 1. 0 will leave. The next thing to do is to take our square. So we can write this as ln f of x all over the theta. We have looked for all of this. Now we take our square. It then means we take the square of this function. So if we take the square, we get something like this. X squared all over theta squared minus 2x all over theta plus 1. So from quadratic equation, if we take the square of this, we get the whole of this. So the next thing to do is to take our expectation. So we move over to this other side of the board. For more on this topic, you need to subscribe to this channel. So taking our expectation, we write the Cramer-Rao inequality as the differential log of our PDF all over the theta all square. So we are putting this to be the expectation of x squared minus, all over theta squared minus 2x all over theta plus 1. So it then means that this will give us an expectation of x, if you are opening the brackets, all over theta squared minus 2 expectation of x all over theta plus 1. So we recall that for Poisson distribution, we have that expectation of x is equal to theta, and expectation of x squared is equal to theta squared plus 1. So the next thing to do is just to substitute what we get here, theta squared plus theta, is to substitute what we get here into this, and substitute this into this. So we move over to the other side of the board. If you find this helpful, you need to subscribe to this channel. So we'll move over to the next part. So it then means from here, we have n to be the differential log of our function all over the theta squared to be equal to, now we have expected value of x squared, which is this, which is theta squared plus theta all over theta squared minus 2 multiplied by what we have as x, expectation of x is theta, 2 theta all over theta plus 1, which is also equal to, if we do the arithmetic of this, we'll notice that this will cancel this. So we'll be left with theta squared plus theta all over theta squared all over theta squared minus 2 plus 1, which is the same thing as theta squared plus theta minus 1 all over theta squared. Of course, if we want to make this the LCM, we'll get theta squared plus theta, this will go over here to give us theta squared all over theta squared. This will cancel this to give us theta all over theta squared. If this cancels this, we'll get 1 all over theta. So it then means that we'll have our expectation which we have taken. Our expectation which we have taken will give us this. Now, we can now multiply with n, our n value. So our n value will give us n expectation of the ln of our function, the log of our function, dot theta all squared will be equal to, we multiply this with n, which is n into 1 all over theta, which is n all over theta. Now, how do we compare with the Cramer-Rao inequality? How do we compare it with the Cramer-Rao inequality? How do we write the Cramer-Rao inequality? To get our final answer for the minimum variance unbiased estimator, we compare this our answer with the Cramer-Rao inequality. The reason is because we have succeeded in getting the whole of this. So, and our Cramer-Rao inequality says that we have 1 all over n multiplied by the expectation of the mean function of our PDF all over the theta squared will be equal to, now, if we take the inverse of this, we'll have theta all over n. So this becomes our minimum variance unbiased estimator of the Poisson distribution using the Cramer-Rao inequality. This is simply how we can get the Cramer-Rao inequality, or how we can find the minimum variance unbiased estimator of the Poisson distribution using the Cramer-Rao inequality. For more on this topic, you need to subscribe to this channel.